Welcome to our today's live. This is John, and today we are talking about this very important topic, which is definitely three-phase. This is an introduction to what most of you top bosses have been asking me to talk about, and I said, why not? I must talk about it because you have asked, and you know what? Because you're the top bosses, then I have no choice but to definitely go ahead and talk about it. Where are you streaming from? Let me know, and so that I can know that we are together in this, my good top boss. So glad to have you here. And as we join in, let us have everything set so that this live stream becomes great for us. Today we are talking about a three-phase, and so it is important for you to, make sure that you understand a concept or two when it comes to three-phase connectivity. And I am here to take you through everything that you require to know, my good top boss. All right, so let us dive right into it. We have connections that come into our transformer. That is the local transformer that we get or we tap our power from, and it is good for us to talk about that, basically the transformer. Mhm. So we have connectivity that comes into our transformer, and at the transformer level, especially now that we are talking about three phase, we have the incoming and we have the outgoing, definitely. So at the transformer, normally you will have that connection there. So if we are starting with the red phase, and then we have the yellow phase, and then we have the blue phase. So allow me to simply use the red marking here, because I try to look for, so this is red, this is blue, this, sorry, I just made a mistake. This is red, this is yellow, and this is blue. Okay. Now on the primary windings, we have the outputs, which are definitely, let me draw them like that. So we will have, the red phase, we'll have the yellow phase, and we'll have the blue phase, and we'll have the neutral. So at least the neutral, because I have, the black here. Let me see how I can have it. So this is the neutral, and this is now our transformer. I was not really good at drawing, so you'll have to forgive me. And then we have these lines here. First, before it gets to, the power line to servers, we will have them drop all the way to, what we refer to as fuse carriers, which are mounted here. So we will have fuse carriers here. Sometimes you may find that they are placed on poles depending on the designers. And we say that electrical engineers are electrical designers. So you will have the connection for the red face there, and then it exits, and then you will have that one for the yellow face. It gets into the fuse carrier where you have a fuse, of course, and then it exits. And then you have the blue face connection. Blue face connection will also get to it fuse, and then it will definitely exit. Now, at the primary windings, we will have those conductors there that come from the transformer. Of course, the red phase, the yellow phase, the blue phase, and finally we'll have a neutral or the return. Of course, again, there is earthing connection that is done at our transformer. You know, a transformer has to be earthed. So this goes to, of course, the load, and we have our trans. Woo! Did I write transformer as it's supposed to be really? What is that? Transformer. That is our transformer there. If you're just joining in, let me know where are you streaming from. And I'm so glad to have you in here. And I have Steve. Steve, thank you so much. You're streaming from 254. Of course, that is Kenya. Steve in says, amazing work, Mr. John. May your electric work shine bright. I've learned a lot and it helped me at the site yesterday. Wow, wow. I love it when people share such great testimonies about how we are impacting them as top heights electricals and electricians. So thank you so much, Steve in, for sharing your thoughts right there. I really do appreciate so much. Yes, so this is a basic representation of, you know, our distribution of power at the transformer level. And of course we have the primary lines coming in from the source. We definitely have red or red phase, we have the yellow phase, and we have the blue phase. So dropping at the transformer. And we said that from the source you'll be able to tell easily where the red phase is, the yellow phase, and the blue phase. Now if you are streaming, let me know, what do you think? How do engineers determine that this is the red phase, the yellow phase, and the blue phase? In my earlier video sometime back, not earlier, I talked about that. I asked a question and we received a lot of your feedback, and it was so great. So this is definitely the supply. Supply is basically three phase for a three-phase transformer. You know, for a single-phase transformer, you have supply coming in also in single phase, and the output you get a single phase. But why do we refer to them as three phase or single phase? If you have these three connections here, you have the red phase, the yellow phase, and the blue phase, it makes it a three phase. Even without the neutral, we have a three-phase connection, because you see this is a three-phase primary connection which feeds our transformer here. And the transformer gives an output also of three-phase connection or three-phase connectivity plus the neutral or the return path for the source of, you know, source of power there. So we have that as you know, our supply there. and then we have our load connectivity. Now, when we are talking about the load, which is three phase, we have, uh, in most cases, you'll find that for this type of a setup, you'll find that this load is fed to single phase connections, whereby we will have a connection from the red phase and the neutral, or from the yellow phase and the neutral, and blue phase and the neutral. So if it is an apartment, that is what happens. But again, we have a connection whereby an entire, property, or an entire industry or establishment, or probably, let's say, a factory, will be supplied with only these three uh, conductors. This is depending on the type of load that is there. And this is normally determined at the point whereby the customer, or the person who is applying for this power supply, quotes what the load is, or what they are supposed to, power their their power supply with. Now, if at all they have a high demand for for the load, then they will be supplied with these three phase. They can have their own transformer in the site. This transformer can either be ground mounted, or what we refer to as GMT, ground mounted transformer, that is a GMT, or it can be a pole mounted transformer. All right. So depending on the size of the transformer, and sometimes also why the customer decides to have their own transformer in a certain room, or enclosed, that is up to them. So they can have a ground mounted transformer. In most cases, that transformer has to be enclosed in a room. You have found that when you visit a place, let's say for those who have been in attachment, let's say in a company, in a factory, which requires that type of setup, you find that there are rooms, various rooms, where you have a transformer room, right? You will probably have a metering room, and then you might also have another room where you have switches. These are normally very tiny rooms, depending on what is in there. You can also have a place where you will have the power factor, or such power factor compartments. you know So we will talk about these definitely when we start getting deep into three phase. But now I want us to lay a foundation about the three phase connectivity, so that we walk together in this journey. I'm not saying that I'm the perfect one, but we are learning together as we walk in this journey. And I appreciate so much the top bosses that are here, as well as the top resident engineers. I refer to you. If at all you normally come to the comment section and reply to the comments on my behalf, we are all one. We are a community in this, and I do appreciate every top boss's feedback when another top boss has definitely inquired about something. So let me know, where are you streaming from? How is this live stream coming along? Do you appreciate these topic that I have introduced, which is a three-phase connection, or a three-phase type of wiring? To begin with, my diagram there is a demonstration or a display of a transformer. And at the transformer level, I have the incoming three-phase connection, as well as the outgoing three-phase connection right there. So you need to understand how these connections are, helping, or how important are they in terms of the connection for this power distribution, which is definitely a three-phase power distribution. Once you understand these, things become easier for you, especially if you are into the electrical field, because when you are making an application for the power supply to your customers apartment, or your customers a business entity, or probably your customers structure. Let's say they are building a home or a business entity. You must be able to come up with all of these designs, because we said that an electrician is basically a designer, and a designer is more or less or more likely like an architect. So when it comes to electrical, an electrician or an electrical engineer is an electrical architect. I don't know whether I'm making sense, because you come up with all these designs. Even the transformer room, it is you to to design how it will be. You need to know that a transformer room has a transformer that will be sitting in there. And so how do you design even the walls? What are the materials that you're using there, considering that you need to ensure that your transformer does not overheat in there, gets enough supply of air for cooling purposes, especially if your client has a heavy load. It means that circuit will be supplied with a lot of current. So this transformer needs to be in a place where there is sufficient air supply. Another thing is safety. Not anyone should access this room. And we also have the metering room, the switches room, where we also have things such as the power factor capacitance that is there. So you really need to design that. I appreciate Nelson Walushimba. I'm enjoying your lesson, my bro. Keep it up. Thank you so much. Nelson is from Zambia. What an honor to have you here, Nelson. Thank you so much for tuning in. Thank you so much for streaming live to our today's session. And I really feel honored to have you in here. So today we are definitely talking about three-phase connectivity, and we are laying a foundation when it comes to the same. We'll talk more when we get into the transformer room. We'll talk more when we get to the metering room. It will get much interesting when we will be talking about power factor. We will be talking about losses. We'll be talking about load balancing or phase balancing. There is a lot that we will be able to learn. Phase uh, load balancing. So we will learn more when it comes to that. Now, uh, when we talk about a three-phase transformer, we will also dig deep about the connections in there, the star connections, the delta connections. We will talk about that. But today I want us to now get into what we refer to as the load balancing or the phase balancing. This is definitely at the the consumer side. Now you see, for us, as I was saying earlier, we will have this connection going all the way to the customer. The customer is supplied with three phase or a single phase, depending on the load that is there and depending on the machines that are likely to be used there. This is determined at the point where the customer is making an application, and they are definitely advised by the electrician. So if an electrician is guiding the customer on the type of connectivity that they need, they guide them based on the load. Because if you say that you just have, lighting points, you have sockets where you will be connecting the load for the customer there, and you do not specify, You need to do a specification so that at the power, the utility, the national utility will be able to understand clearly what type of load are you being connected to, as well as what is the expected, you know, total load that will be there. So this will simply be able to guide, uh, you know, to guide you on what you require to connect, the type of load to be connected there, and also the size of the cables, or rather the uh, yeah, the cables that supply the power to that entity. Because again, you don't just have cables or conductors of any size, because let's say you have a very heavy load that will be connected there, then it will determine the size of the cables. And whenever we talk about, especially even the single phase connectivity, the three phase, the drop cable and everything, the size of the cable plays a major role, because if the size is too small for the load, there will be a lot of issues, especially once the loads are connected. You might have issues such as the cable burning the insulation, because it cannot the insulation cannot stand the current or the heat generated by the cable due to the load that has been connected to it. So we need to be very careful about that. Again, that is where now an electrical technician plays a major role when it comes to advising the client on the type of connectivity that the client is looking for. So at this particular point where we have this supply, if at all it is an apartment, you will simply have the red phase, the yellow phase, the blue phase, and the neutral supplied to the customer's apartment, or to your apartment, if you are the person that is making the application. But if you see these three conductors supplied, to even if it's an apartment, then you definitely know that that is a heavy load, and they have their own transformer to to service them. It's not a public transformer. So you will also have this connection, the three-phase connection together with the neutral, being supplied to also another investment, or another building, or probably even if it is an industry, or not an industry really, but you know an investment whereby this person requires three-phase supply, yes, but not as heavy as compared to the one who will require only the three-phase connectivity. So now let us get into, let's say, an apartment that is supplied with the red phase, the yellow phase, the blue phase, and the neutral conductors. To that business entity use all of these cables, then we are going to understand that, we are going to learn about that. If, for instance, someone is supplied with that, power supply, we want to understand how does that play out, you know. So if from our transformer we have this type of connection, and in other countries we will have an extra wire here. In fact, let me use a different marker. We will have an extra line for other countries, making these distribution, three-phase distribution, 5 conductors. What is the purpose of this extra line here? Let me know, my top boss. What do you think, for countries where you have an extra line that is down there? Let us get this live stream as interactive as possible. And if you will be watching this video as a recorded version, smash that like button if you are already getting some value of three-phase. And so glad to have you as well. Now, my top boss, what do you think is the purpose of the fifth conductor in some other countries? Specifically in my country, Kenya, you will only have these four conductors if you have been passing and being very keen on the roads where our power distribution is normally at. You have only noticed the four. In fact, let me have these in black, because definitely a neutral is that is in our country again. I have friends watching from Namibia, from Zambia, and you probably have a different kind of a setup. So forgive me when I'm using what I am used to or what I'm familiar with. So we'll have the first conductor as the red phase, the second conductor as the yellow phase, the third conductor as the blue phase. So that makes three-phase distribution. That is why we refer to it as a three-phase distribution. And then we will have a neutral. This neutral serves these three phases, especially if this type of connection is landing into um, a connection where the distribution in there, it is in single phase. So you will have a phase connection from the red phase, and then will be returned by a neutral. If let's say you have machines that are using the three phase, then you tap simply from there. All right. But I'm asking for countries where you have the fifth conductor, what is it for? In fact, even in our country, there are some electricians, electrical engineers, who will employ or deploy. I don't know. I'm not so good at English, though yeah. So you will find that an electrical engineer will opt to also include the conductor, the fifth conductor here, to go back all the way to the transformer. And my question is to you, top boss that is here, what do you think is the purpose of that fifth conductor there? Right? What is the purpose? Let me know. So at the point where we have the load, let's say it is an apartment. So if we have this apartment already here, at the meter box, or definitely at the meter board, because uh, you can't have a three-phase distribution and have a meter box. No, 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 no. Why? Because it means that there is a high chance you will have several energy meters there, and you will definitely be having what we refer to as um, these are what we refer to as the cutouts. So we will have three cutouts here, and then we will also have another cutout specially dedicated for the neutral connection. Now we'll get to understand that this cutout here is very, very important, this one here. But before we go to that, we'll have a drop cable. This drop cable will be connected at these conductors here, these conductors. And then of course, because the first one is the you know the red phase, will have it I think I made a mistake, but I think I will manipulate my drawing. We'll have the blue phase, and then we'll have the yellow face dropping to that other one, and then we will have definitely the neutral. See, I'm going to manipulate my drawing until I have what I intended to have here. So if you are streaming live as an electrical technician, I appreciate you taking your special time to be here with me. It is a great Sunday, and I always love to chill out with my electrical technicians. Why am I referring to you as my electrical technicians? Because you are my top bosses. Without you, definitely, I would not be here doing this. And in most cases, you find that what I am doing is because you asked for it. And so I really need to, to do as you say. Your wish is my command, top boss. Yeah. So I will also have this connection coming in here, and we will have that dropping in there, and then we will also have this type of connection coming all the way. It drops to somewhere. Let me not take it all the way there. It drops to somewhere there. I'm still asking the question, what do you think is I think we can have that drawn like that. Trying to manipulate my drawing here. So that at least it can make some sense. So what I'm having here is a drop cable. This is a drop cable. We were told that an arrow in a science class means something. So you don't just come up with arrows in electrical drawings because it will be signifying something. Is it the direction of a DC current? So let me not use an arrow. Let me just point at it. So meaning this is a drop cable, a three-phase drop cable, meaning it has uh, 5 connections there. We have a connection for the neutral or the return. I have the connection for the phase, the 3 phases, and so this is this is neutral. Okay, then we have our red phase here, we have our yellow phase here, and definitely we have our blue phase here. Very important. So this is at the meter board. Let me squeeze somewhere here the word meter board. If you're just joining in, thank you so much for your time. Smash that like button if you're already getting some value from this channel, and thank you so much for subscribing to my channel. It means a lot. We are almost 7,000 subscribers as of today. Never did I thought that I will reach such levels, but because of you, my top boss, here we are. So I really do appreciate your contribution. I really do appreciate your likes, subscription, and any engagement that you have with my content, it means a lot to me. So I really do appreciate even your presence here. I salute you, my top boss. And if you are an electrician, I refer to you as my resident engineer. So I thank you so much for being here. So this is a three-phase distribution into an apartment. If not an apartment, it is probably a factory that does not have a lot of power or high power requirements whereby they can share the transformer with the public. Remember, I began by saying that if at all you have a high power demand, you will have your own transformer that is distributed specifically for your needs. That transformer supplies your load requirements, and most likely, if you have heavy machines that you are using, it could be three-phase machines. Of course, if you have a transformer in there, you have three-phase machines or three-phase connectivities that require that type of connection. And so this is our meter board here being supplied by power from that transformer there. And it definitely means that the load there is heavy, which cannot be supplied by a three phase. You're doing a great job, my friend. I'm watching you from the UK. Wow, awesome, Mohammed Kamara, thank you. I'm originally from Sierra Leone and I'm learning a lot from your channel. Keep it up, my brother. Wow, wow, wow. Mohammed Kamara from UK. Really do appreciate your feedback. Thank you so much for being here and for choosing my channel and also following what I teach here. So you said you have learned a lot. Thank you so much. I also have a good friend of mine who says that amazing work, Mr. John, that is David, says, may your electric work shine bright. I've learned a lot and it helped me at the site yesterday. I love, getting these messages from you, my top bosses, because it means the world to me, knowing that I can choose a certain topic, come to discuss about it, and I get your reactions. It means a lot to me because it indicates that you are finding some value. So I really do appreciate. So this is at the apartment level, and then we might say that we have several units in that apartment. Let's say in that apartment, we are taking a residential apartment, let me just write it here for the sake of clear understanding. Residential setting. So if we have a residential setting here, we definitely have the meter board distribution. Now, being a residential, you probably have several stories there or several units. So let's say a residential, you have, that apartment there. And then that apartment has, let's say, 4 floors, first floor or ground floor, second floor, third floor. No. So you have first floor there. You have, no. Let us do this. We have the fifth floor, have the fourth floor, the third, we have the second, we have the first, and we have the ground. We can even have the what do we refer to it? The floor that is just under the ground floor. It's referred to as the basement. Can even have the basement where we probably have the car parking area. And at that particular point, we have uh, let me just have my camera there so that yeah, everything is visible. Let me know. Yes. So if we have these floors here, this is your client who is coming up with this development. This development runs from the basement all the way to the fifth floor. So at the point where they are being connected to power, there are so many things that you need to consider as an electrical technician. And that is why I said an electrical technician is a designer or it is an architect, right? An electrical technician is an architect. Why? Because, for you to do a perfect work of electrical, you must be able to come up with these designs. So this is all an electrical technician who will be doing it. You are a designer. So your client has or is coming up with this, development here. Let's say it is referred to as John's Suites, or Top Height Suites. These are palatial homes, great real estate investment by yours truly, John Gatehi, or probably by our company, which is Top Heights Electricals and Electricians. So we have Top Height Suites running all the way to the fifth floor. We have several units. We have we have 2-bedroom units per floor. We have probably, let's say, 4 units. 1, 2, 3, 4. We can even have 5 because we can. All right. So how many floors do we have? We have 5 up to fifth floor. So inclusive of the ground floor, we have 6 floors, and we have the basement. We also have the common areas such as the staircase, or probably we have a lift section, and we have areas such as the security and all that. Now, this is a 3-phase distribution. How do we ensure that this apartment is fed with this 3-phase distribution system, and we do not overload a single phase or a specific phase? Because how many units are those? We have, 5 2-bedrooms per floor, running from the ground floor all the way to the fifth floor. If at all we overload one specific phase, either it is the red or the yellow phase or the blue phase, that is what I normally refer to as a recipe for disaster. So we must ensure that we do a good balancing, whereby we are able to balance the distribution properly and have our phases well distributed, to the loads. Because if you don't do that, then you are inviting a problem whereby you find that that transformer will have an issue, and it will also mean that you will have problems with the national power distribution, because if you have not balanced your load, then you may cause issues with their power distribution, or probably you may cause issues with the transformer that is supplying you with power, especially if that transformer is serving several people, not only you, or probably not only your client. So if it is serving several people, then it will mean that you have to consider all of those factors whereby other people are not affected by the load imbalances. So you find that in most cases, uh, a national grid supplier will insist that you balance the way that you have distributed your load to each and every phase so that you do not have issues, over there. Meaning, if you have connected your load, have you ensured that you balance the red phase, the yellow phase, and also the blue phase? It is important for an electrician or an electrical engineer to ensure that your load, or probably your power distribution is done in a way that is balanced. You know, you do not just have the connection done haphazardly, because it will bring an issue even to that establishment or an apartment. And we will touch up especially more about that connectivity whereby you have the neutral not well connected, or probably the phase connections not well balanced, and that will bring a very big problem, especially to the drop cable. If you have not done a proper connection, you will find that if one phase is overloaded, or if one phase, you know uh, is connected to a lot of appliances or a lot of houses, meaning that the load drawn that is drawing current from that specific phase is too heavy, it will translate to that specific circuit being strained, or specific circuit having, or probably the line having a lot of challenges. So if it is the blue phase, and I've been using this red marker here without knowing that I had a blue. So just to make sure that everything is okay, let me use at least a different coloring there. Now, as an electrical technician, there is another aspect that we refer to as color coding. Very important. How I wish I had a yellow marker here. I've been trying to look for a yellow marker, but to my disappointment. So we have the blue there. And thank you so much for joining in, and also for your likes. Smash the like button if you're getting that value today. So we have an apartment. This is John's Suites, or Top Height Suites. So we want to balance this type of connection here. We balance it so that we may ensure that we do not have issues. We will talk about the load balancing and why it is important, especially when we will be talking about power factor correction or connections there, where we will have the topic of capacitance coming in. It will be very important when we'll be talking about that. There are machines which lead to those issues. So this is an apartment running up to the 5th floor. Inclusive of the ground floor, we have each floor having 5 2-bedroom units. Now we want to connect our power in a manner that we will not overload a specific phase or 2 phases, and then not balance the load to the others. So we want to distribute this demand to these 3 phase that we only have. We only have one drop cable, we only have one transformer that we can use at a time. So we have the red phase, the yellow phase, and the blue phase, and most importantly, we have the neutral. Why do I refer to it as most importantly? It acts as a return path for all of these phases. Why? Because when you get at this level where we have now these units, the two bedroom units, I mean the two bedroom units, we have single phase connection there because we'll have either the red phase going to a certain house, the yellow phase or the blue phase, and all of them have to go back to the source, the transformer. Remember, we've been saying that an electrical connection is complete, or an electrical circuit is complete, if there is a return path, and the return path is created by the neutral connection or the neutral conductor. So let's say we have these two bedroom units at each floor, which they are 5. Then it means that we have single phase connections, meaning we have the live, and we have the neutral connection. Of course, we have the earthing connection, but for today's lessons, we are specifically insisting on the live and the neutral when it comes to three-phase connectivity, load balancing, as well as phase balancing. So when it gets to our meter board, we will now have, let's say, how many houses are these? For each floor, we have 5 houses. We have 6 floors, which means we have 30 units. 30 units. Is my math really making sense? We have from first floor up to the 5th floor. So each floor has 5 2 bedroom units. So that means we have 30 units in total in these Jones suites or apartments. 30 units, and we have red, yellow, and blue phase. Common sense will tell me that I will distribute equally 10, 10 units for each phase. Another 10 units for the yellow phase, and another 10 units for the blue phase. Yeah. So this is dedicated to, I'll probably take the ground floor, which has 5 2 bedroom units, first floor, which also has 5 2 bedroom units, and connect them to a red phase. I will take the second floor and the third floor, which both have 10 2 bedroom units, connect them to a yellow phase. And then finally, I will take the fourth floor and the fifth floor, connect them to, a blue phase. And then there is something that is remaining. I have the common area connections. This one, I keep on forgetting. I'll connect them to that. All of these units are served by this neutral connection here. So that is how I will balance. Assuming that my tenants or my customers are connected with the same load demand. Being a residential or a house, do not expect much that will be connected there. Okay, don't expect much connectivity that will be happening there. You do not, of course, expect machines that will be in your houses. I will kick that resident out, of course. So I take the fourth floor and the fifth floor, have them dedicated to a blue phase. Sorry about that. have them dedicated to a blue phase. And then I will take the third floor and the second floor, can connect them to either a yellow phase or a red phase. There is no order there. And finally, the first floor and the ground floor, I will connect that to the red phase. So glad to have you here. If you are watching this video on recorded version, I want to thank you so much. We have set the pace for three-phase tutorials or three-phase connections. I have a lot of top bosses requesting for three-phase connections, requesting for industrial type of electrical installations, and we have kick-started everything now. We will talk about many connections when it comes to the three-phase. Industrial connections, we will talk more about that. And if you are fired up to learn more when it comes to that, smash that like button. Let me know. Is this, a topic that we should delve deep into it, especially because we have been covering single phase connections. And if you ask me, I'm super excited, super delighted to be, talking about the three phase connectivity or industrial type of electrical connections. We'll talk about motor connections because you have asked about that as well. We'll talk about the connections between star, delta, delta star, and all those direct online. All of those connections, we'll talk about that. When we'll get to three-phase machines, we will do a lot of that. Also, in the industries, you have this supply here, and then they have a ground-mounted transformer. How does that play out? We'll visit all of these because we cannot buy a transformer and place it at John's workshop, you know uh, to require a lot of money for us to achieve that. But since we have industries or companies that are having them, we will try as much as possible to get many interviews with them so that they can tell us. If you are streaming this and you are an electrician who is working in these setups in your company or in your industry, kindly inbox me and I will be glad to come to your company and do an interview. You can even speak to the management on my behalf and ask them, grant top heights electricals and electricians an opportunity to interview you, our top resident engineer, so that we can be able to learn together. And if you will be teaching us, or probably if you will be guiding us through that, we will give you a lot of credit because you are a great resident engineer, and we will appreciate you. Wow, we have a resident engineer here by the name Clemax. Wow, Clemax is a great resident engineer, and I always appreciate you. Thank you so much for always commenting and always giving us feedback, especially when it comes to um, the questions that top bosses ask. I have Anzan2 TV says, sorry, I'm late. Just got here. I was at your TikTok account. Wow. Anzan2 TV, thank you so much. You are much welcome. I really do appreciate your presence. Hit the likes up if you are already getting some value. Yeah. Thank you so much. Glad to have you here, my top bosses. So today we are talking about three-phase. Three-phase, and so glad to have you here. So glad to, be the one taking you through this important subject right here. So thank you so much, Clemax, for being here. Azantu TV, such a great honor as well. So we have said that you have five floors. No, you have six floors inclusive of the ground floor, and each floor has five units. These are two-bedroom units, so making them 30 units. 30 units, you divide that by three, which means is our three-phase supply there. Once you divide that by three, you definitely have the three-phase balanced, whereby you connect each phase to 10 units like so. And then, of course, all of this will be served by the neutral connection. Now, as an electrical technician, when you are doing this type of setup, you must be very careful with this cutout here. Why? This cutout is a return path for all the 30 units. At least for phases, they are supplying electricity, to only 10 units, and that's it. And these phases are relying on this neutral connection here, or this neutral cutout, as a return path. So all of these will be returned here. You cannot uh, take the neutral connection lightly, because even as our resident top engineer Clemax knows that if you have a loose connection at the neutral or at the return, there is a problem there, because electricity will not find a very good path or a safe path or a credible route for it to return back to the source. Remember, we said that electricity has to come from the source, which is the transformer, get into an appliance, and then go back to the source to complete a circuit, to make a complete circuit. And this neutral provides that path, the return path. So as the designer, you must also ensure that you take good care of that neutral, the return path. So we have already balanced. When it comes to now the common areas, John Suites or Top Heights apartments has, security lightings. It has a pump connectivity which pumps water. What else? No major thing. So again, the electrician can decide, where do I take this connection from? You can as well decide that you're going to balance, especially when it comes to the security lights. There are times whereby you don't have the red face. The red face is missing, or the yellow face is missing, or the blue face, or two of the faces are missing. So what do? You can either balance, or there is a technology that you can use whereby if the red face is missing, it can switch to the available face, so that you do not have a blackout, total blackout in your apartment. If at all there is a face that is missing, and you had probably dedicated that the security lights in that apartment to that specific, you know uh, face. So you ensure that you balance. I mean, you ensure that you have a system whereby if the red face is missing, your security lights can tap from the yellow face if this is what is available, or the blue face. We talk about the pumps. If, for instance, you have the pumps, you can also do the same. Now, at this particular point, because you are the designer, the electrical architect, you can as well advise your client that, uh, we can also switch to solar, so that we have a system whereby if at all their power is not available, we can have solar backup, whereby if there is a power blackout, we have solar power supplying power to to the apartment, whereby we do not have an issue with security lightings. I've seen in so many apartments whereby the electrician did a good job at advising their client. They have solar panels on the roof so that these, wow, that electricity pole has come in very well. I had not thought about it, but again, this, does it really look good? Let me draw the neutral wire well, like so. And also at this particular point, yeah, a designer must have some drawings which are making some sense. Yeah. Remember we've been talking about a drop cable so much, and we said that a drop cable should be connected in a manner that it will not allow rainwater to get into the meter board. Very important point you cannot neglect there. So this is how our connection is. And then I had asked a question: if you are in a country whereby you have 5 conductors, you know, you of course have the red phase, the yellow phase, the blue phase, the neutral, and then you have the fifth. What is the purpose of that? Some countries will have that. In some instances, even in our country, I've seen that. So, my top boss, what do you think? Let me know in the comment section. What is the purpose of that fifth conductor here? And I'm specifically drawing it with this color so that you already have a clue. Do you have a clue already about that? Yeah. So glad to have you here. I'm so honored to have you streaming this live stream of today here. We're just laying a foundation on three-phase type of connection, and we have said that for a three-phase, we have started with what is familiar to us. What is familiar to us is definitely a three-phase connection to our homes, a three-phase connection to the apartment that you probably reside in or you own. I have top bosses who are top. And you have, let's say, a story building here. Our story building here is referred to as John's Suites or top height suites. This is our apartment, top bosses. So we have uh, floors running all the way to 5 floors or the 5th floor. Each floor, we have said it has 5 units, each of 2 bedrooms. These are 2 bedrooms units. There's a guy here by the name John has invested really well, real estate investor. So each floor has 5 2 bedroom units, and we have said that we are going to balance. All of the units now add up to 30 units. We have simply divided by 3 to get 10 units per phase so that we do not overload a specific phase. I've said that there is an extra load that is coming from the common area of this apartment. This load is lighting as well as pumps. We can even have 1 pump or 2. And we also have the lift. So again, we will dedicate that to, especially where we have a lift that requires 3-phase connection. I don't know much about the lift, but I will get a top boss who will be able to take us through about the lifts. And then we have those, the pumps, the lift, and the lighting for security and the stairs. We will connect that to, we'll also balance. If you, let's say, can have the pumps dedicated to a red phase, can have the lighting dedicated to a yellow phase. If the lift requires a single phase, I don't know much about it, we'll connect it to a blue phase so that we have things balanced up. But if the lift requires three-phase, we definitely make use of the phases. That is how we will balance it. Now, another important aspect when it comes to this type of connection is the drop cable. The drop cable, we will be looking at the size specifically. This size of this drop cable must be able to handle the load that John's switch draws from that three-phase distribution. Now, again, as the electrical engineer, who is the designer, the electrical designer, who is also an architect when it comes to electrical, you must be able to advise your client. When they are making that application, you must be there to guide them. The type of load that you expect there, you must be able to fill in that form the load, so that the cable that is distributed to your client's apartment is the correct size, so that it can be able to handle the load. Again, you must be able to assume the scenario whereby all of these customers are at home. You know, all of these residents are at home and they have connected their appliances to the electricity. You know, you cannot dictate to a customer who is in fifth floor at apartment or at room at house number 5 that they should not put on their microwave because there is someone who is using their washing machine in the ground floor, because it will overload the faces. No, or it will strain the cable. No, you must assume the scenario whereby all of these customers in John's Suites are using their appliances, whether they are taking a shower, whether their fridges are on, whether they are all of them using their washing machines, they are cooking using their electric cooker. Those are the worst scenarios I'm talking about. So this cable must be able to handle that. Another important thing is definitely the connection. If you do lose connections at these cutouts, there is a problem. Because from this cutout here now, we are saying 10 units. Each unit has an energy meter. Each unit has a DPMCB, a double pole miniature circuit breaker. This is the main switch that switches power to those units, so that you will have 10 you will be able to organize your meter board so such that you have 10 energy meters here. 1 2 3 4 5 6 7 8 9 10. All right, so these are energy meters, and above here we have the DPMCBs, again 1 up to 10. You have connected the red face to these. You have connected the neutral, the return path to all of these MCBs. So these are MCBs and these are energy meters. Energy meters. From the energy meters, definitely now power will go all the way to the units or to the houses. So it comes to the drop cable, to the specific face cutout, and then to these, double cutouts. I mean, to double pole switches that you have connected there, to the energy meters. From the energy meters all the way to the houses. So here it is clear that we have a single phase connection to the houses. Those are 10 houses. Assuming all of those houses have been connected, to heavy loads, fridges, microwaves, washing machines at the same time. If your connection at these cutout is compromised, there is going to be an issue there. You will keep on replacing these cutout. If the neutral connection is compromised, not well connected, a great disaster. Why? Now here we have this connection that I've introduced here, the green marked connection. This one is acting as a return, I mean as the earth connection. All right. So if you have a loose connection, in most cases you'll find that this connection here, because it's an earth connection, does not have a lot of strands, or um, it is not bigger in size compared to other conductors. So if you have a loose connection here, power will tend to utilize this green path here. And in most cases, you find that once it burns the entire cable insulation, exposing all of these wires in the air. Those are scenarios which I've experienced, by the way. So if this one burns, it burns the entire insulation, meaning the entire cable is burned. And as it burns, it may burn the insulation of the neutral, the face, and I mean all the faces. Once these cables or the wires inside clash, it leads to a short circuit, which may result to burning, or a high power surge, a high voltage spike in the appliances of these customers, meaning all of these 30 customers will be at risk of losing their electrical appliances, or they can even be subjected to an electrical hazard, such as an electrical fire to their homes, and you do not want that. So from the point where you're making an application, you must ensure that all of those are factored in. Take care of all of that. So that is it for today, and we are just laying a foundation. I will talk more about the electrical connections when it comes to three-phase, industrial wiring, industrial setup, industrial machines, how they are connected. We can even go further at explaining how they operate. We will talk about that definitely. If you are a top boss, you would like us as Top Heights Electricals and Electricians to visit your company, your industry, where you work from, so that we can be able to learn much more when it comes to that. I'll be glad to work with you. Just let me know through our email, which is info@topheightselectricals.com. That is info@topheightselectricals.com, and we'll be glad to work with you in explaining to our top bosses how three-phase distribution works. If you are a student that is looking forward to learn more before you get into the field, definitely you are in the right place, and I'm so glad to be the one taking you through. If you are an experienced electrical technician or an electrical engineer in this field, I am so glad to have you here. Where we go wrong, we ask for your guidance and your advice, and we really appreciate. Also, your input is highly valued. If you want to learn much more when it comes to these type of connections, then be sure to check out for more information, even in our show notes, where I will be linking the links there, so that you can be able to learn about various aspects when it comes to electrical engineering. Electrical engineering is so simple, it's so easy. You can be able to understand if you dedicate your time and your effort to learning it. Thank you so much for your time. My name is John, and this is Top Heights Electricals and Electricians. So glad that you could join me in this live session. Yeah, live again and getting some value. This is from Kipkorir Dennis. Wow, Kipkorir Dennis, thank you so much, for tuning in to our today's live stream, and also for giving your feedback. Always a pleasure, Kipkorir. I thank you so much, and continue interacting with my content. Continue giving me feedback, and I will definitely do as you please. This was courtesy of you for requesting that we need to now get into three-phase discussion, and we are here now. Top bosses, we're here. So we'll continue talking much more and give much more practicals and you will be able to enjoy. The coming season where we are talking about electricity in three-phase setup, industrial setup, is going to be a fantastic one. And I hope to be with you all the step of the way. My name is John, and this is Top Heights Electricals and Electricians. Thank you so much for joining in. Goodbye.